Hello, welcome. My name is ML Qcal. I am a student of planning and GIS, and in this channel I talk about how to do mapping with ArcGIS, QGIS, and ArcGIS Pro. So if you are interested in this topic, kindly subscribe to this channel for me, hit on the bell icon, and hit on the like button of this video. So in today's video we are going to learn how to create land surface temperature with Landsat 7. So if you watch this video, that is the link over there. That video will teach you how you can download Landsat images for various analysis such as land surface temperature, land use land cover map, NDVI, and NDMI. Yes. So you can watch that video. And I am using the Landsat 7. And normally the Landsat 7, when you download them, they come with scan lines. Do you get it? So you see this one. There are scan lines. Have you seen the scan lines in there? Have you seen? You can't do analysis with images with scan lines. So normally you download the image, the Landsat image with corresponding GM. So we have band 3 and we have GM band 3. Do you get it? When you watch the video I spoke about, it speaks about that GM. And now I will, when you download them, you are going to use a GM to fill the scan lines. Do you get it? And to do that, we use QGIS to do that. So you can watch this particular video too. It will teach you how you can use QGIS to fill the scan lines of Landsat 7 image. So if you watch that video, that is the steps I went through to be able to correct the scan lines. And now my Landsat images are ready. And one other thing, the Landsat image with the GM, it comes with two band 6, VCID band 1, VCID 1 and VCID 2. So check here. So you see that we have band 6 VCID 1, band 6 VCID 2. Yes, I used AI and I did research and I was able to know that the VCID band 6, the VCID 1 is favorable to Kumasi, where I live. So if you are watching this video, you can also use AI or do your research to know if the VCID 1 is favorable to your location or it is the VCID 2. But aside that, the bands that you need are band 4, band 3, and the MLT text file. Do you get it? So if I talk about the MLT text file, the MLT text file is the one that when you download it, yeah, so this is the MLT text file. Yeah, so when you are downloading the Landsat image and you watch the video I spoke about, they have MLT text. You see? So you download the band 6, band 4, band 3. Like I said, the band 6 are in 2 folds. So you check the one that is favorable to your location. Then we are going to go through 3 steps. It's 5 steps, sorry. We are going to calculate top atmospheric spectral radiance first. Do you get it? And to do that, we use this formula. This one, the first one is top atmospheric spectra. ML is radiance multiplicative scaling band. The band 6 and this. Do you understand? And we are going to use the ArcGIS box to do that. So you get the ArcGIS box, then you go to spatial analysis to map algebra. Then you select it. When it comes like this, when you go to the formula, ML, radiance multiplicative scaling factor, radiance multiplicative band 6. So you go to the MLT text file, radiance multiplicative band 6, radiance multiplicative band 6, then you look for it, radiance multiplicative band 3, radiance multiplicative band 6 VCID 1. We are not using this, we are using this. Have you seen it? So you copy that one. We are using VCID 1, not VCID 2. So you copy the radiance multiplicative band 6 of the VCID 1, then you come here. The formula starts with a bracket opened. So you open a bracket here. And one other thing, the 6.70 should be written as 0.0. Then you get it. You remove the point. 0.06708. Then you can clean this. We've converted it to decimal figures. Have you gotten it? Then multiplication sign will come. Multiplication sign will come. Then Cal. The Cal is the band 6. Do you get it? Qcal, raw band 6. Multiply by the VCID band 6 we are using. Yeah, so the Qcal, so the multiplication will come, then the band 6 will come. And you see that the bracket is closed. Do you get it? Then you close the brackets. When you close the brackets, plus sign is here, the addition sign, then you bring it. you go back, there is AL. AL is Radiance Additive Scaling Factor, Radiance add band 6. So you go to the MLT text file, it is there. Radiance add band 6, Radiance add 1, Radiance add, do you get it? It is here, and it is a negative sign. Do you get it? So you copy, so you see that it is a negative sign, so you can bring bracket here like that. Are you getting me? You see that plus sign? If the formula is not correct, it will be there. If it is correct, it will vanish for you to know that you are on course. Do you get it? When you are done, you can come here and specify where you want it to be saved. Do you get it? If you've been watching my videos, you know that normally I come here, go to a folder, then I specify where I want it to be saved. But we can just go forward and click OK. Sometimes too, you can copy it in case it fails to run, then you come back, then you paste it, then you go forward. So I have copied it. Let's go OK. So it is running. So we've been able to calculate the top of atmosphere spectral radiance. So we can come here and rename it. You hover the mouse on it, TOA. Do you get it? We are done with step 1. Then we move on to step 2. Calculate brightness temperature, BT, and the formula is K2. So you go back, you open a bracket, K2. What is K2? When you go to the MLT file, you see that K2 constant for VCID1, K2 constant for VCID1. Do you get it? It is this. Then you copy that one. Do you get it? Then you come here, then you paste it there. After K2, there is a division sign. Then you go back, division. The next one is ln into bracket kn. What is the ln? When you come to the side, the conditionals, you see ln. You select that one. A bracket will open. You go back to the formula K1. So the K1 constant, when you go there, it is the K1 constant for VCID. Normally, always know the type of the band 6 you are using. So we are dealing with VCID1. So you paste the VCID1 K1 constant there. Then the division sign is there. Then you bring it. When you go back, LA, what is it? So the LA, this one, is the top atmospheric spectral radiance we calculated in bands, step 1. Do you get it? So it will be divided by TOA, the one we found in step 1. Have you gotten it? Plus 1. Then you come back, plus 1. Have you gotten it? Double brackets. We add another bracket here. Then you go back, minus 273.15. Minus 273.15. Have you gotten it? So we are done. We are done inputting in the formula. Have you gotten it? When you are done, then you click OK. So now the BT is here. So I can still come back here and name it BT. We are done with BT. Have you seen it? So the next thing we are going to do is that we are going to calculate for NDVI, Normalized Difference Vegetation Index. And with this one, the formula is float into brackets band 4 minus band 3 divided by float into brackets band 4 plus band 3. So we go back. The float is here into brackets band 4 minus band 3. Is that not it? Yes. Then you divide it by another float band 4 plus band 3. Are you getting it? Okay. So we are done calculating for the NDVI, right? So you can come here and write NDVI. Are you getting it? The next step is that we are going to calculate for PV, that is proportion of vegetation. Proportion of vegetation. And for that one, you open a square root. So you come here, you find square here. When the square is opened, then you open another, you make the brackets open double. Do you get it? Then you come back here, NDVI minus NDVI minimum. This is what they are saying. So the NDVI we calculated in the previous step is here, minus NDVI minimum, the low NDVI figure over here. So you can come here, hover it on it, or you can write it if you have the time. So NDVI minus negative NDVI minimum. Have you gotten it? So nega will be positive, but you can leave it like that. Then you come back here, divided by bracket open, NDVI maximum minus NDVI minimum. Do you get it? This NDVI maximum. So you can paste this one here, because that is the NDVI minimum. So they are saying this NDVI high, the maximum NDVI over here, minus NDVI minimum. Have you gotten it? So at the end of the day, it is going to be this plus this, this plus this. And again, the year will be positive. Are you getting it? Are you following? Then the bracket is double over here. If you like, you can add the bracket here because of the negative figures. But then the formula, it will still say that the formula is not correct. So you can just leave it like that, so that the machine will deal with the negative. Do you get it? So let's go back. Brackets close, brackets, double brackets, double brackets, double brackets, double brackets. Do you get it? And they are all in the square. And there's a division sign here, and here NDVI minus this, NDVD. Are you following? When we are done, then we can even copy it before. Then you click OK. It is done. So you can come here, PV. The next step is that we are going to calculate land surface emissivity, E, and the formula is 0.004. 0.004 times PV times the PV we just calculated, plus 0.986 plus 0.986. Have you gotten it? When you are done, you can click OK. So E is here, so you can name it E. Like I said, you can always specify where you want it to be saved. Do you get it? And before I continue, please, if you are finding this video very helpful, kindly consider subscribing to the channel for me if this is your first time, please. And if this video is like, if you are gaining some value from this video, you can hit on the like button to like it for me so that it can go far, and you can share it. If you have any question, you can put it in the comment section so that we can interact. Thank you very much. So E is here. The last step is that we are going to calculate the land surface temperature. Have you gotten it? So now LST is equal to BT. You see the BT we calculated in the second step. BT divided by division sign, brackets open, 1 plus another bracket open is there, right? Another bracket open is there. Then this, what is this? They are saying it is effective wavelength of band 6. It is constant, 11.45. Then you copy it, then you come and paste it here. Do you get it? Then times BT again, times BT. Have you gotten it? Then after that, divided by C2. Divided by C2. What is C2? C2 is Planck's second radiation constant. It is this. It is also constant. So you copy it, then you paste it here. Do you get it? Multiply by ln. Do you get it? ln E. So you put the E we just calculated in here, and the brackets close is double. Have you gotten it? So this is it. But I think I didn't close the formula, the bracket before the C2. This bracket I didn't bring it. That is why you still see this. So let me bring it. Now it has vanished. Have you seen it? So that red sign always alerts you that your formula is correct or not. So this is it. When you are done, then you can click OK. So the land surface temperature map is here. Do you get it? So I can go there and write LST. Do you get it? So I can even come here and change it, the color. Have you seen it? The areas with high temperature are this side, but the area is too big. We just want to know where our study area is. So this is the map I'm going to use. This is the boundary. So I'm going to carve out my boundary so that I get my boundary. Do you get it? So let me bring it here. This is my area. I'm studying here, so I can, let me just export. I can just select it, create selection layer from selected feature. Yeah. So let me go here and select any side. Remove this, left with this one. So let me go and click my study area. So LST. I just saw the selected area. Clip. Okay. So I'm done. So I can uncheck this. Have you seen it? So this is the study area. You can see that with the Landsat, because the area is very big, highest temperature is 74, lowest temperature is negative. Do you get it? The area is very big. But when I clip my study area, the highest temperature is what? 40, 25 at slow. Have you seen it? So I can just come here and repeat the same thing. So this is 2010 image. So in 2010, the highest temperature of the area was 40, then the low was what? 25, and the highest temperature zones were these zones, and these areas were low temperature zones. Have you seen it? Yes. You can even go to the properties, symbology, stretch it, choose this, and also, so the high areas are here, and you've divided it into this. You can also go there and actually reduce it to 3, so that it will be high, moderate, and low area. Have you seen it? Yeah. So you can come here, add your scale, legend, and those stuffs. The links over there. These are videos that I teach you how you can design a map to look very, very, very nice. Yes. So this is how you calculate for land surface temperature of an area with Landsat 7. In my next videos, I'm going to do how you can do it with Landsat 8 and 9. And with that one, we have 2 approaches. So stay tuned. Thank you very much for watching, and I would like to see you in my next video. Bye bye.